Hi and welcome everyone to our lesson in our electrical design course. In this lesson, we are going to learn how to do the electrical design of a panel based on all of the knowledge we learned in the course. We learned before about the selection of breakers, selection of cables, neutral, earthing, and so on. Now I would like to have an example in order to combine all of this knowledge to understand how to do the electrical design of a panel. This example is brought from Professor Abdulmonem Jaban. This is a book or an Arabic book about electrical design. So I try to translate this example to because it is really helpful and it will help you learn a lot about electrical design. So first we would like to design a panel board which consisting of three motors and two motors. Three motors which have a 30 horsepower, each one is a 30 horsepower, and two motors which is a 20 horsepower. Now the cables of these motors are on one cable tray and they exist in a temperature of 50 Celsius degree. Okay, so what do we would like to do? You can see this single line diagram representing what we would like to do. We have here our panel or our bus bar. So we have an incoming cable. We would like to know this cable rating, and we have it's the main circuit breaker of the system. Then we have the distribution of this cable. So we have circuit breaker here and here, and the cable for each of these motors. So we have 30 horsepower motors. We have three motors, okay, and one spare giving us a total of four motors. So in reality we have three motors but one spare giving us a total of four. And for the 20 horsepower we have two motors and one spare. So two motors and one spare, we will have a three motors in total. Okay, so in our system here, how many motors are connected? We have for the 30 horsepower we have only three connected. For the 20 horsepower we only have two connected. Neglect the spare. Okay, so let's start. First, let's talk about the 30 horsepower motor. So in order to select the circuit breaker, we need to find the rated power. So the rated power of this motor or this circuit breaker, I rated, is equal to the horsepower multiplied by 1.5. Okay, so we multiply the horsepowers by 1.5 to convert from horsepower to rated ampere. Now where did we get the 1.5? Simply as you can see here. Now remember that the rated current, let's say I rated, okay, of a motor, okay, equal to, we have first the power divided by root 3, since it is we are talking about line to line, multiplied by V line to line, multiplied by the power factor. Okay, like this. So we have the power in watt. Okay, so we, in order to convert the horsepower to watt, we have 30 multiplied by 746. Why is this? To convert from watt, from horsepower to watt. Okay, divided by root 3, and V line to line, the line to line voltage, which is dependent on the country. As an example, I'm using here the voltage in my own country, which is 380 volt. Okay, and assuming a power factor of 0.8. Okay, so if you take 746 divided it by root 3 multiplied by 380 multiplied by 0.8, all of this will give us 1.4 or approximately 1.5, which I'm using here. So you can see a 30 horsepower multiplied by the resultant of all of this, which is 1.5. Okay, now this value is not constant for all countries, dependent on the line to line voltage. Okay, according to the line to line voltage, you can have a formula which you can use to convert horsepower to ampere. This is just an example. Okay, So now I have the rated power. How can I select the circuit breaker? Simply take this rated power and divided it by safety factor or a derating factor of circuit breaker. So we will say circuit breaker, current of the circuit breaker required is the rated power 45 multiplied by a safety factor of 1.25. Okay, so this multiplication will give us 56 ampere. Now we have to go, so this is a circuit breaker rating required. This is a minimum current required. So let's go to the table which we have seen in our course. You can see 56 amperes. This is all of the circuit breakers rating. Here I'm talking about the molded case circuit breaker and the miniature circuit breaker. So 56, you can see here, this is the closest value, 50 ampere, which is not enough. However, 63 ampere is enough. So we are going to select the 63 ampere because it is the next higher one. Okay, and the difference between them is not very large. Okay, so the circuit breaker selected is 63 ampere because it is the one which is available in the market. Now what about the cable? So I would like to select the cable of each of these motors of the 30 horsepower. So dependent on the value of the circuit breaker current, we can select the cable. So if you remember, as we discussed in the course, we said before in the previous lessons, I cable, the current of the cable is equal to the value of the circuit breaker divided by the derating factor. Okay, so circuit breaker current is a 63 ampere. What about the derating factor of the cable? So we have to know the conditions of this cable. So first, we know in our problem or in this example, we said that it is in conditions of 50 Celsius degree. Okay, we said 50 Celsius degree. Okay, so this is the first point. Second point is that we said it is not buried in the ground. It is an on cable tray which is in free air. So it is an in cable tray, which means there is a distance between cables, which means the grouping factor is 1 or unity. The cables are not affecting each other because there is a distance between them. Now, since they are in free air, we are concerned with the derating factor of air temperature. So we have 50 Celsius degree and we are going to use PVC cables, which are having a rating of 70 Celsius degree. So we are going to use this derating factor, 0.82. So as you can see here, 50 Celsius degree PVC, derating factor 0.82, and grouping factor equal to unity. Okay, so what we are going to do is taking the circuit breaker, divide it by 0.82. So I cable equal to 63 divided by 0.82. So it will give us 77 ampere. So this is the current required by the cable, the rating of the cable. So we have to go to the catalog. As an example here, this is from LCD catalog. Okay, so from LCD you can find here the current rating dependent on if it is laid in the ground or in duct or in free air. Now here we said before that we are talking about free air, so we are going to use the value of this column. Okay, as you can see here. Now second step is that we need to find a cable that can withstand 77 ampere. So if we see here, we have 18 ampere, 22, 31, 39, 53, 72 ampere and 94 ampere. You can see 77, the closest value is 72. It is lower, yes, it is lower. However, it is the closest value. You will see that 94 is very, very large compared to this. So the closest cable is 72 ampere. So this cable is the one which I am looking for. Okay, so this cable is having a cross-sectional area of 16 millimeters square. So I'm going to use, this is a 4-core cable, so I'm going to use 4 from multi cable, we are going to use a copper PVC 4 multiplied by 16 plus 16 millimeter square. What does this mean? 4 core cables which having a rating of 16 millimeter and plus 16 millimeter representing the earthing. So the 4 core here representing the 3 phase, okay, 3 phase, the neutral, 1 neutral, okay, for the 4 core, and 1 for the earthing, 1 for the earthing, okay. So this is the earthing and this is the 4 core representing the 3 phase and the neutral, okay. So as you can see here, this is a cable. We selected the circuit breaker and the cable of the motor itself. Now, why did we choose an earthing of 16 millimeter? Remember, we discussed before the earthing and we said that when the cable is 16 millimeter square, the phase cross-sectional area of the phase 16 millimeter or less than 16 millimeter, the earthing will be equal to the phase. So as you can see, earthing 16 equal to the phase because the value itself is less than 16 or equal to 16 millimeter square. Now, second motor is a 20 horsepower motor. We are going to do the same value, the same idea. First, we will get the rated current. So I rated is equal to the horsepower multiplied by 1.5, which I explained before. This value can change dependent on your own country. So you need to do your own calculations, okay? So it gives us 30 ampere. So we'll take this value and multiply it by a safety factor 1.25 to get the circuit breaker rating, which is 37.5. Now, looking at the circuit breaker ratings, you can see 37.5, the closest value is the 40 ampere, okay. 32 or 40, yes, 40 is better because it is close to this value and higher than the required current, okay. So the correct one is 40, not 32, okay. So the circuit breaker equal to 40 amps. Now we have the circuit breaker, we need to select the cable. So again, the cable current is the circuit breaker dividing by the rating factor. So as you can see, the same idea, we have 50 Celsius degree. We are going to use PVC cables, not cross-linked polyethylene. We are going to use PVC, so we'll use this factor 0.82, same as before. So you can see I cable equal to circuit breaker divided by 0.82. So we'll have 50 ampere, okay. Now going to the catalog again, you can see 50 ampere we need again it is in free air, cable tray free air. So we need 50 ampere. So if we look here, 39 is very far, 53 is very close to this value. So we are going to use the 53 cable. Okay, 53 ampere. So this will be corresponding to 10 millimeter square. So our cable will be as before, 4 multiplied by 10 plus 10 millimeter square. Okay, all of them are equal to each other because they are small cables. Okay, so if we look at our panel, we can see that the 30 horsepower, this is the cable we selected, 4 multiplied by 16 plus 16 millimeter square. And this is our circuit breaker, molded case circuit breaker, 63 ampere. And this one is also molded case circuit breaker of a 40 ampere, based on our own calculations, okay. And this is the cable 4 multiplied by 10, the one which I just selected. Now the next step is that we need the main cable and the main circuit breaker. So we will start by circuit breaker, then we will get the cable. So we have this currents. Remember, we have a 20 horsepower and 30 horsepower motors. How many of them? We have 2 of this and we have 3 of the 30 horsepower, okay. Now how can we select the main circuit breaker? Remember that this circuit breaker, okay, is the main circuit breaker that the current flows through it. and provides power to the system. Okay, so there is a rule that we use to get the main circuit breaker. The current of the main circuit breaker equal to 1.25 multiplied by the largest current in the system, or the largest branch in the system, plus diversity factor multiplied by the rest of all of the currents except the largest one which we have used here. So first, what does a diversity factor mean? It means that all of our loads are not operating at the same time. Okay, as this is in the distribution network, we have all of the apartments in the same building, in the same floor, they are not operating at the same time. Or even in the same apartment, not all of the devices are working at the same time. So there is a diversity factor, which means that we are going to reduce the total current. Okay, so anyway, if you look at here, we have a factory. So factory, what does this mean? It means that all of these systems are operating. So the diversity factor will be 1. Why? Because all of these loads are operating at the same time. All of the machines in the factory are operating at the same time unless something else according to the owner requirements. Okay, so we have 1.25 multiplied by the largest current. So we have 2 motors, each 30 ampere, and 3 motors, each 45 ampere. So what is the largest current in the system? The largest current is the 45 ampere. So we have a branch with 30 ampere, another branch with 30 ampere, then 3 branches, 1, 2, 3, each 45 amperes. Okay, so which one is the largest current? 45. Any 45 is the largest current. So let's say we selected the largest one, which is 45. So let's say we selected this one, plus diversity factor, which is 1, multiplied by the total current except the largest one. So we have 30 plus 30 plus 45 plus 45, the rest of the currents, as you can see here. So the main circuit breaker current is 206 ampere. Okay, so how can we get the cable again? Similar as before. Before this, again, we need to find the circuit breaker suitable for this application. So 206 ampere, if you look here, we have 160, which is very far and low, then 206. We have 200 ampere or 250. 250 is larger, so as you can see, 206 is between 250 and 200. Which one you think we should choose? We should choose the 200 or the 250? Of course, we are going to choose the nearest one to the 206, which is 200 ampere. So we are going to choose the circuit breaker of 200 ampere, which is very close to 206. Remember that we here have a safety factor. So if the current or the rating of circuit breaker is lower, there is no problem at all. So as you can see, circuit breaker will be equal to 200 amperes. Okay. Now what about the cable? So simply we will divide it by the derating factor as before, and there is nothing different. They are the same temperature, 50 Celsius degree, the same derating factor 0.82 in this temperature. Okay, so we will divide it and we will get the 250 ampere of our cable. So if we go here, we have our cable 250 ampere, so we will go to the catalog as we did before. So it is also in free air. So look at this column, and we need 250. So let's see, 250 is between 242 and 275. Which one is closer to this value? The 242 is closer to the 250 than 275. So we are going to select this one, and this is corresponding to 120 millimeter square. So our phases will be 3 multiplied by 120 plus neutral of 70 millimeter, and the earthing will be 70 millimeter. Okay, so this gives us the phase 120 millimeter square. Okay, now why did we choose the neutral 70? Because as you remember that when the cable is larger than a certain value, we will choose our neutral cross-sectional area of neutral is equal to half the cross-sectional area of the phase, which is half of 120 is 60 milliampere. However, in the real life, we have 70 millimeter square. Okay, it is not the same as the phase, but it is half of it, close to half of it. Okay, similar to the neutral, to the earthing, it will be also half of the phase. Okay, we learned this in the previous lessons. So if you don't know this, get back to the lessons of earthing, selection of earthing cables, selection of neutral cables, and so on. Okay. Now finally, after collecting all of these data, this is our panel board. We have the circuit breakers. As we selected, we have the incoming cables and outgoing cables and everything. So this is how can you select the cables and the cross-sectional area of them and the circuit breakers of the system. Okay.